is video 5 from the 2011 Form A test. This one seems very familiar. It's like another one I've just recently done. They've given us dw dt, so they've given us the derivative of w. They've given us an initial value on w. And this feels like it's heading for a separation of variables down here in part C. But in part A, they just want you to find, well, I want to do two things. But first, we need to find the line tangent to w at 0. So, once again, to find the equation of a line, we simply need a point, and we need a slope. So I need to find my slope at time 0. Here is my derivative based on time. Notice, however, though, that there is no place to plug in time 0. Notice this is w within dw dt. So in other words, the rate of change of w, of the tons of garbage, I guess it is given to us in terms of how much it weighs at that time. So what that means is I'm not plugging in 0, I'm plugging in the weight at time 0. And the weight at time 0 looks like 1,400 tons. So if I plug in 1,400 and subtract 300, that's going to be 1,100. And 1,100 times 1/25. And so what's that going to be? It's going to be 25 goes in 110 4 times, 10 left over, 25 goes into 100 4 times. So it looks like my slope is 44. And then my point is the point at time 0. My weight is 1,400. Alright, so it looks like I get an equation of a y-intercept and a slope. So it looks like I have 44. I guess it's, let's see, what's my independent variable going to be? I guess it's t. Plus 1,400 times 0, it's 1,400. I'm losing 44 pounds every 25. Yeah, I'm not sure on my independent variable here. It may not be a t. No, we'll go with it. I think we're good. And so now we've got this, and we want to use it to approximate the amount y at the end of 3 months. So basically we have some, excuse me, hit the zoom. We have some curve doing its thing, and we've just found the tangent line. And so instead of plugging into this curve, which we don't know, I'm going to plug in to the function and get a value, and there shouldn't be much difference between the value on my line and the value on the curve. So the value on the line would make a good estimate for the actual answer. So that just means I'm plugging in 1/4 for t, and so I get y is equal to what, 1,411 tons. Let's fix the zoom here. Alright, so here is my answer to part A. Part B wants me to find the second derivative in terms of w. So I come up here and look at dw dt, and I need to find the derivative of it. And I think it might be easier to rewrite dw dt by distributing the 1/25. Let's see, that's going to be every 4, that's going to be 12. And so now the second derivative, please note we're taking the derivative with respect to t. There are no t's. This is implicit. So the derivative of 1/25 w is going to be 1/25 dw dt. Derivative of 12 is 0. So here's my second derivative, but they said write it in terms of w. So I'm going to go back and look and see that dw dt contains w's. So my answer is really going to be 1/25 times dw dt, which is pretty much that. And 1/625, I guess I could write. Okay, and then determine whether your answer in part A is an underestimate or an overestimate of the amount of solid waste in the landfill at time 1/4. So, if you look at this, if my graph looks like this, then my value would be an overestimate. So what would have to look like if my value is an underestimate? If my graph was this shaped, and I did a tangent line, now my value on my line is less than the actual value. And so what are the difference in those two shapes? It would be their concavity. So I need to look at the concavity of W when we're dealing with this. So that would be at time 0. And at time 0, my ton is 1400. So that means my second derivative, which is what this is, if I plug in 1400, I'm going to get a positive number. So that means that I'm concave up, therefore the line I found was tangent and was below, therefore it is an underestimate. Determine whether it is, and it doesn't ask me to explain my answer, so I should be good. Alright, and finally we have part C, and they want me to find W. So I need to do separation of variables. So I'm going to move all my W's to the other side. I don't have any T's, but I'll move them to the right side if I did. That gives me 1 over W minus 300 dW equals 1/25 dt. So the antiderivative of this is going to be natural log of the absolute value equals 1/25 t plus c. So now I need to find c. I know an initial value. I know at time 0 the weight is 1400. So I get the natural log of, and that's a positive number, so I don't need the absolute values, the natural log of 1100. Is that right? And so that's what C equals. And we go back, we plug it in right here, so I get the natural log of W minus 300 equals 1/25 T plus natural log of 1100. I solve for W, so I exponentiate. I get W minus 300 equals, when I exponentiate on the side, I get e to the 1/25 t plus ln 1100. And I still don't know about the absolute values if I need them or not, so I'm going to hold on to them for one more second. So I can split this up using my exponent rules. And e to the ln 100 is just 1100. So I get that W minus 300 equals 1100 e to the 1/25 t. Okay, so now with the absolute value, I know that whatever is inside of here can be positive or it can be negative. So technically I would write W minus 300 equals positive 1100 e to the 1/25 t. But I also, and then I'll solve that, but I also should write negative 1100 e to the 1/25 t. Now I got to figure out, after adding 300, which one of them actually works. And I think it's going to be the positive one. But the way we do that is we plug in the initial value they gave us and we see which one it works for. So this simplifies to 1100 e to the 125th t plus 300. And let's try it here. So I plug in time 0. So e to 0 is 1. I get 1100 plus 300 is 1400. If I do it over here, t is 0. I get 1. I get negative 11 plus 3. That does not give me 14. So there is the specific function. Let's make sure I address the question. Yes, I have. Okay, let's see how we did. All right. 1411 tons. That's what we got. We found the slope. We found the point. The second one we said, yeah, 1/625, w minus 300, and w is greater than 1400. Therefore, interesting, this isn't exactly what I was thinking, but what did they say? And w is greater than 1400. Therefore, the second derivative is greater than 0. Oh, I see what they're saying. So at time 0 we were 1400, and then as time went by, the values got bigger, I think is what happens. So the derivative would continue to get bigger as well and be greater than 0. So it's concave up. They said what I said, just frankly I think I did a better job, which is unusual. And then here we are with our part C and all of the points that go with the separation of variables. So 1, you separated it. 1 for antiderivatives, 1 for a plus C, 1 for finding C, and then 1 for solving for W correctly. Okay, that's kind of a tough question. Let's quickly look at the scoring guide, or the, you know what I'm saying, the commentary. Overall student performance was very poor. 54% didn't get anything. Those who did score points, they did pretty well. The average was only 1.63. So if we go back and look at the scoring guide, there are 5 points available here at the end, 4 of which are very simple. So even if we didn't get any other points on this question, there's 4 points for you right here.